everyone, welcome to the video. Today we are trying to solve the problem leaders in an array. In this question, we are given an array of positive integers and we have to identify the leaders in that array. Now what is a leader? An element of the array is a leader if all the elements to the right of it are smaller than it. For example, here 17 is a leader because this 17 is greater than all the elements to its right. Similarly, 5 is a leader because it is greater than all the elements to the right, but 4 is not. So we are trying to solve this problem today. We won't directly jump to the solution, but try to see step by step that how do we think through and reach the solution. To begin with, let's first try to understand and note the key things that we are given. We are given an array of positive integers and we have to identify leaders. And who is a leader? Leader is someone who is greater than or equal to all elements on its right. And that makes rightmost element always a leader. Let's see an example. So if we are given this array, we can see that in this array, the leaders identified will be 17, 5 and 2 and no one else. Because all of these elements are greater than all elements on their right. Now if we consider our solution as a black box, we are taking input as an array and returning output also as an array or a list. So what will be our function signature like? Our function will take basically an array and its size and will try to return a list of integers back. To solve it, let's try to think what is the simplest way we can solve this problem. The simplest we can think of is that we pick every element one by one. And for every element that we have picked, we check all the elements to its right. So for example, if we have picked 17, we check all the elements to the right. Now, if all the elements to the right are smaller than our current element, then that element is the leader. So we put that element in our result list. And if this condition is not met, we do not put in the result list. What will be the time complexity of such a solution? Picking each element one by one takes big O of n. And for each of that element, we are moving till the end of the array towards its right. So again, for every element, we need big O of n time complexity, which makes the overall time complexity as big O of n square. Now, is this efficient? No. Why? Because we are seeing every element so many times. Also, for every element, do we need to compare it with all the elements to the right? Or will that be enough if for every element we compare it to the biggest element to the right? Even this will be enough, right? For example, if for 16, we can compare it with the biggest element to the right, which is 17. So 16 cannot be a leader. Similarly, for 17, we can compare it with 5. So 17 is a leader. For 4, we can again compare it with 5. So 4 is not a leader. So at every element, we only need the biggest element to the right to compare with. Now let's try to apply this to our example. This is a blank array that we have taken, and for every position, we will fill that what is the maximum element including itself to the right. So let's start from rightmost. So here the maximum element including itself is 2. Now let's see for 5. The biggest element to the right of 5 is 2. So including itself, the maximum element here becomes 5. For 3, the biggest element to the right is 5. And including itself, the biggest remains 5. Similarly for 4, also it remains 5. Now for 17, the maximum element to its right is 5. But if we include itself, the maximum element is 17. And similarly for 16, the maximum element to its right is 17, and including itself also, this remains 17. And we can see that here we find the leaders 17, 5 and 2. So how did we do this? To calculate max at I, we just checked max at I plus 1 and the current element AI. And whichever was the maximum was max at I. For example, here we checked that for max at this position, we checked what was max here and we compared it with this element and we got the max here. This is a very common sub problem that we'll have to do in many questions, where for every position we have to kind of store what is the maximum element or minimum element to its right, including itself. But we can see just one problem here, that these elements are repeated. So we cannot just output this list. What we actually need is, we just need 17, 5 and 2. Okay. So this is like we start from right and we find some max element. Then we keep moving towards left. We compare every element with this max element. And then we find some new max element. And then we keep moving to the left and then we compare every element to this new max element. So it is happening like whichever was last inserted, we need to compare it with first. So what kind of data structure would suit it best? The data structure we need is stack. We'll start from right to left, we'll find a max element, we'll put that in stack. Till the time the max element remains same, stack will not get updated. As we find a new max element, we update that in the stack. So at the end, we'll have in the stack 17, 5 and 2 from top to bottom. And then we can convert this to the list and return. Now let's see how do we put this thought into algorithm. So we need a stack. So we will have a stack initialized. Then rightmost element is always a leader. So we'll put the last element in the stack. Next, we know that we have to iterate and we have to iterate from right to left. So we will be iterating here. And what will we have in every iteration? In every iteration, we'll have two things. We'll know what is the current element and we'll know what is the top of stack. So we'll compare the two. If current element is greater, that means we have received a new leader. So we can push that in the stack. Otherwise, we'll just continue over the loop. And we'll run this loop from second last element till the first element. So this will be like a for loop. And once we are done with it, the stack will have all the leaders. So we'll convert stack to list and output that result. And as we can easily see, the time complexity for this will be big O of n, as we are iterating only once. Now let's see how does the code look like for this algorithm. You can also find the link in description. So first of all, we just initialized a stack. We pushed the last element into the stack. Then we have to iterate from n-2 to first element, right to left. And in every iteration, we compare the current element with the peak of stack, with the topmost of the stack. And if the current element is greater, we push that into the stack. Now the final task remains to convert stack to list. So we have used a method here to keep the code modular. In this method, we just declare a result list, and till the time stack is empty, we pop every element, we add that to the list, and we return that list. So to summarize, we first understood the problem with an example. Then we tried out the simplest approach. In the simplest approach, we picked every element one by one, and for every element, we compared it with all the elements to its right, and we checked if it was greatest among them all. If it was, we considered that as a leader. But that took higher time complexity, big O of n square. So we tried to optimize it. To optimize, we kept an array where we stored all max elements to the right for every position. And this we could do in big O of n time. How? We use this formula that max at position I will be maximum of two numbers, either the max at position I plus 1 or AI itself. Max at position I plus 1 would denote all the maximum element among all the elements to its right, including itself. Finally, we used stack to not have duplicates among the leaders. We saw the algorithm and then we also went through the code whose link is in description. If you have any doubts, please feel free to comment below the video. In the next video, we'll meet with some other problem. Thank you for watching.